In this video, I'm going to have a look at solving trigonometric equations. So I picked out one where you have to change the domain and also one that's a little different to what you normally expect with these type of questions. These are both A-star level questions, by the way. So it tells you solve this equation, giving an answer in terms of pi. So without using actually you can still use the calculator. Okay, so what's the best way to go about doing this? If you've done year 2 maths, you might have thought double angle formulae, but I don't think that's the best way. I think the best way is to divide each individual term by cos of 3 theta. The reason why is because we know that when sine of an angle, let's say 3 theta, is divided by cos of an angle, where the angle is the same, then that's going to be equal to tan of 3 theta. Not only will this term become tan of 3 theta, but dividing this by cos 3 theta will cancel it out, leaving you with just root 3 for the second term. So let's write that out. We have tan of 3 theta, cos 3 theta divided by cos 3 theta will cancel out to give you 1. So we have minus root 3 for your second term equals 0 divided by cos 3 theta, which is just 0. You don't want to solve for theta by adding root 3 to both sides. So tan of 3 theta is equal to root 3. Now, in order to solve this, you first have to triple the domain, because right now our domain takes into account values of theta, but we need it to take into account values of 3 theta. So tripling everything on the domain, 0 times 3 is 0, theta will become 3 theta, and then pi becomes 3 pi. Now, when you do the inverse tan of both sides, we say 3 theta will be the inverse tan of root 3. Okay, what is the inverse tan of root 3? Okay, something's telling me it's a third pi, but I'm just going to double check on my calculator. So inverse tan of root 3 is, okay, it is a third pi. But then what values repeat up until the end of this domain? Now this is where I'd advise you draw a graph. Some people like to use the, what's that method called? The cast diagram, but you don't have to, honestly. I'll show you why. So we have pi over 2 has the asymptote. We're going to try to draw it all the way up to 3 pi, by the way. If you add 1 pi, that's where values repeat. So the next asymptote is at 3 pi over 2. The next asymptote after that is at 5 pi over 2. 5 pi over 2. It looks something like this. And then we're drawing it all the way up to 3 pi, which is around here. So across 0, up to where we're drawing it. What we found is a third pi, which will correlate to somewhere around here. In our domain, we know there's 2 more values that it has to cross before it ends up at this position here that we're taking it up to. So what are those 2 other positions? Well, like I said, the tan values, they repeat every pi radians. So if you add a pi onto a third pi, you get 4/3 pi, which is the next time that it repeats. If you add another pi onto that, you get 7/3 pi. So these are your 3 solutions for 3 theta. But what we want are solutions of theta themselves. To find that, you divide each of these individual solutions by 3. So a third divided by 3 is a 9th pi. 4/3 divided by 3 is a 4/9 pi. And then 7/3 divided by 3 is 7/9 pi. And these are your 3 solutions, which just magically fall into the range in the question. Okay, let's now move on to part 2 of the question. Given that this expression is true, find cos x in terms of k. So whenever you're dealing with this, you want everything to be in terms of one variable, whether it's all in terms of sine, all in terms of cos. In this case, you can't really transform cos to make it in terms of sine, so it makes sense to make sine squared somehow in form of cos squared. We're able to do that because there's an identity linking them, which is sine squared plus cos squared is equal to 1. If we rearrange this to make sine squared the subject, we get sine squared of x is equal to 1 minus cos squared of x. What we're replacing is 4 times sine squared x, so that's 4 times everything on the right hand side. We can say 4 sine squared x will become 4 minus 4 cos squared x. And then we can just add on the rest of these variables. So we have plus cos x equals 4 minus k. Now that we've done that, we can put it into the format of a quadratic and then go about solving it. So I'd recommend we take everything to the right hand side because there's a minus in front of the squared term, which I don't really like. So adding 4 cos squared to the right hand side, you get this. Taking away cos x from both sides, you get this. The 4 and the 4, they'll cancel out actually, leaving you with just minus k on the right hand side. Just a reminder, we took everything to the right hand side of the expression to form this equation. In order to solve this and get solutions of cos x actually, you want to use the quadratic formula. So we know all quadratics are in the form ax squared plus bx plus c. A is the coefficient of x squared, which happens to be 4 in this case. B is the coefficient of cos x in this case, which is minus 1. And c is the constant at the end, which is minus k. The best way to do this is to, well actually, the solutions of cos x is what you get when you put the values of a, b, and c into the quadratic formula. So you can say minus b, which is 1 in this case, because minus 1 is 1, plus or minus. If I'm going too fast, by the way, please do rewind. Some students prefer me going at this pace, especially with these A-star questions. Square root of b squared, which is minus 1 all squared, minus 4, I like to put everything in brackets, by the way, multiplied by a, which is also 4, multiplied by c, which is minus k, all over 2 times a, which happens to be 8. Let's focus on simplifying this square root. Minus 1 all squared is just 1. 4 times 4 is 16. 16 times minus k is minus 16k. And then multiplied by minus 1 is plus 16k. So we have cos x is equal to 1 plus or minus the square root of 1 plus 16k all over 8. And that's your final answer actually for part A. In part B, we're going to use this now to find all the values of x. Remember that, okay, so it's giving you a value of k actually. So we can just take that value of k, which is, oh, I think it might be worth it if I just erase all of this so I can like bring the expression up higher above so you can see the question while I'm having a go. So I'll just quickly do that. Pardon my nose, got a bit of a cold. Okay, so when k equals 3, let's start by putting k equals 3 into this expression. Cos x equals 1 plus or minus the square root of, well, 16 times 3 is 48, plus 1 is 49. The square root of 49 is just 7. So we can honestly just put 7 here. All divided by 8. Okay, that means there's two solutions. We either have cos x is equal to 1 minus 7 over 8, which is minus 6 over 8, which is just minus 3/4. Or we have cos x equals 1 plus 7 over 8, which is 8 over 8, or 1. What's all the solutions for this? Well, if we do the inverse cos of minus 3/4, let's do that, minus 3/4, that's 139. Now, there is another solution within this domain. If we briefly draw out the cos graph, just labeling a few of the domain values, we know that it crosses at 139, which is around here. So the next time we'll cross is somewhere around here. And because of the reflective nature of the cos curve, we know that if we do 360 take away one value, we get the other value. 360 take away 139 is equal to 221. Perfect. The other value is where cos x is equal to 1. You do the inverse cos of 1, or you can just pretty much see the diagram that it crosses at 0 and 360. Now you have to be careful because you have to look at if both of those values are included in the domain. So like 0 is included, so greater than or equal to 0. However, 360 is not included in our domain. There's no equal to on this domain. So you take these three solutions and they're your final answer for this question. Now you might have spotted something. The root of 49, it can be 7 or minus 7. Whether you take 7 or minus 7, you'll still end up with these two values of cos x, which is why I didn't take into account. If you did spot that, then well done. Pretty hard to spot. But yeah, hopefully this video makes sense. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.